All right, today we're going to write some equations of lines. We've been graphing some, and now we're just going to kind of go backwards and take lines and write equations of them. So here we go. Really two methods. We're going to use either the slope-intercept form as one method. The only time, to be honest with you, we're ever going to use the slope-intercept form to write an equation is if we know both of them. If we know the slope and the y-intercept, it's good to use. Otherwise, the best thing to use is called point-slope form, which is this right here, y minus y1 equals slope times x minus x1. That is what we're going to use the most. I'm going to go ahead and warn you. And you can do that when you're given a slope and a point, or if you're given 2 points, we're still going to use point slope form. So familiarize yourself with that one right there, because that's what you're going to see a lot during this video and tomorrow's lesson. All right, the first slide though says write an equation that has a given slope and y-intercept. If they give you that stuff, all you have to do is write it out. Remember, slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. So you can just write 3x plus 1 equals y. That's all you got to do. Same thing on number 2, even with the fractions there, y equals mx, so negative 3/4 x plus 7 halves, and you're golden. All right, there's your linear equation, just slope-intercept. If they give it to you, that's the best thing possible. All right, step it up a notch. What if they give you a point and a slope? Write an equation of a line that passes through that point and has that slope. If they give you a point and a slope, you're better off using point-slope. That's kind of like redundant, kind of like no duh, point-slope. So I'm going to do y minus my y-coordinate, which is 4. The slope is negative 3, and I'm going to do x minus the x-coordinate, which is 5. Now, your job is to put it in the right form, either slope-intercept form or standard form, whichever way they ask you. So this side's pretty much set. The right-hand side, go ahead and distribute your negative 3 there. And to finish up, I'm just going to take the 4, cross the bridge to the other side, make it plus 19. And that should be it. Now, you can double check, look at your slope. You can also plug in 5 down here for x, and it should equal 4, which it does. So there you can kind of check it as you go. All right, let's see here. This one introduces 2 more things. We've talked about this before, parallel and perpendicular. Write an equation of the line that passes through this point, and A is parallel to this line, and B is perpendicular to that line. Now, looking at this line, hopefully you can look at that and tell the slope is negative 4. Remember, y equals mx plus b. So if I'm going to go parallel to that one, I'm going to use the same slope and use that point. So I'm going to say y minus the y-coordinate is the slope times x minus the x-coordinate. Now, when I do x minus that x-coordinate, same thing as plus 2 there. So I'm just going to distribute the negative 4 and then move the 3. And if I move that 3 over, obviously it becomes plus 3, so I get a negative 5 right there. And that's the parallel. Remember, same slope. Part B says perpendicular. So it's going to use the same point. The only thing that's going to change here is the slope. If this is my slope for parallel, remember perpendicular is opposite reciprocal of that. So I'm going to take the reciprocal and change the sign, put a 1/4. And that gives me y minus 3 is 1/4 x. And if you do 2 times 1/4, you get 2/4, which is 1/2. So all I have to do is move that 3 over. Now, if I move that 3 over, it's going to become a plus 3 over here. And if you do that, all you do is you do 3 times 2 plus 1. It's 3.5. 3.5, if you do 3 times 2 plus 1, you get 7 halves. And you're golden there. All right, so no big deal. So if you get parallel, perpendicular, use the slope they give you and the point they give you. They give you a point and a slope, so you use point slope. All right, what if they give you 2 points? Write an equation of the line that passes through this point and that point. Well, really, if they give me 2 points, I can find a slope anytime I want to. We did this the other day. You do y minus y, y2 minus y1 over x2 minus x1, which would give me 12 over negative 3, which is negative 4, so my slope is negative 4. That's all I need. Now I have 2 points in slope. It doesn't matter which point you pick, but you got to pick one of them and then use your point slope form. To be honest, I know 5 and negative 2 is a little smaller. I'm going to pick 2 and 10 only because they're both positive. I know that's kind of a wimping out a little bit, but again, it does not matter which one you pick. I'm going to go y minus 10, negative 4, x minus 2. It's not a really big deal which one you pick. Y minus 10, distribute the negative 4, make that negative 4x plus 8. And then the last thing you do is again, move your 10 over, make it plus 10, so you get negative 4x plus 18. And again, you can plug in, to check, you might want to plug in that point, just plug in the 5, and make sure you get negative 2 when you plug that in, and I'm doing that in my head right now, and you do. So that's it. Point slope form, again, I told you, point slope form over and over. One more slide. Okay, in the school year beginning in 1993, 2 million females participated in high school sports. That's our first point. I'm going to go ahead and write that. In 1993, there were 2 million. Let's just keep it like this. Remember, it's in millions. And in 2003, the number had increased to 2.86 million. So let's keep it like that. Remember, these are millions. Write a linear equation that models female sports participation. So there's my 2 points again. Find your slope. You're going to do your y minus y over x minus x. So I get 0.86 over 10, which is really 0.086. So there's my slope. Pick whichever point you want. I'll pick the first one. Y minus 2 is 0.086, x minus 1993. And just distribute that 0.086x minus, I'm going to need my calculator for that one. Excuse me real quick. I'll open that up. 0.86 times 1993 minus 17, 13.98. And then just move the 2 over. If I move the 2 over, it becomes plus 2, which would give me negative 1711.98. Now, don't forget that is actually in millions, so when you plug in your x there, your answer will be in millions. Might have been easier even to keep the millions in there and not worry about the decimal, but oh well. Anyway, hope that wasn't too bad. Stuff you should have seen before in Algebra 1. We'll review it again tomorrow when you come into class, and I'll see you then. See ya.